Hello students, in this tutorial we will quickly learn what is the bisection method and then we will see how to write a code in MATLAB for this bisection method. So let's start. So for illustrating the bisection method I have taken this function, and this means that I want to find the root of this equation. 4x minus 2 is equal to 0. Now I can write this as f of x. So I have used this MATLAB code to plot the figure which I have pasted over here. Now you can see this y is f of x. For x is equal to 0 the value is this, and so on. So you can see the value of this function for x from 0 to 10. Now we know that the bisection method is based on the theorem which states that if a function f of x is continuous between a and b and f of a and f of b are of opposite sign, then there exists at least one root between a and b. So let's see, in this let my a is this and b I'll consider as 6. So you can see that between a is equal to 0 to b is equal to 6, you can see the function f of x, this is your f of x, that is y, is continuous from obviously it is also continuous till 10, but just to shorten a bit length I have taken b as this. So b is equal to 6. So you can see easily that f of x is continuous, and f of a, this value is f of a. So I'll write this as f of a, and this one value will be f of b. So you can easily see that f of a is less than 0, negative, because it is lying below 0, and f of b is greater than 0. So what does the theorem say? That obviously there will be a root in between these two values a and b. Graphically what you can see that this is the root which we are interested in, because this is cutting the x-axis for approximately for this value of x, like this is you can see from graph this is around 4 point something. So for if you put x is equal to 4 point something, you will get f of x is equal to 0. You can see that this also is giving that this graph is cutting the x-axis at this point. So your f of x will be approximately equal to 0. So what we are interested in finding this value, I'll write this as p. We are interested in finding the root, that is this p, for which value of x our f of x is equal to 0. So now let's see how to apply the bisection method. So the first step is what? The first step is to find a and b such that f of a into f of b is less than 0. You have already seen why we are doing this, because this will guarantee that okay, in between this a and b we are having root somewhere, because the function is changing its sign from negative to positive, so obviously it has cut the x-axis somewhere. So now when we know that okay, our root is in between these two values a and b, so for the first iteration what we will do, we will calculate this. I have written p1 for the first iteration. What we will do, we will sum a plus b divided by 2. So in this case if my a is 0 and b is 6, I'll get 3. So this is somewhere around this. My p1 is equal to 3. So this is my f of p1. Now what need I do? I'll check again the value of f of p1. Value means the sign, that is if it is negative or positive. So I can easily see that this value is negative over here. So what does this tell you? That the root will now lie in between these two interval P1 and B, because see, earlier you were in this big interval. Your interval was so big. Now what you have done in the second step, your interval of searching has lowered to half. Now you will search your root in between 3 and 6. So f of b, since f of p1 into f of b is less than 0, so in for the MATLAB programming, what you need to do is set a is equal to p1. Now your a is upgraded with this value p1, because now your root will lie in this smaller interval. In the next iteration, what will you do? You will again do, since you have set a, you can write a plus b divided by 2. Since p1 is now a, or this you can write it as p1 only if you have any confusion. So p1 plus b divided by 2. So 3 plus 6 divided by 2. So this will be around 9 plus 9 divided by 2, it is around 4.5. So you can see that you will come somewhere here. Now if you see what is the value over here, you are getting a positive value f of p2. You can write it as p2. You can see that this is positive. So your root will lie between 3 and 4.5. So now what you have done, you have again shortened the length of finding the roots. Now you are in this, which is the half of the earlier length. So you can see how you are approaching towards this root, which is our interest, this one. How you are dividing the interval into half and half, and you are approaching towards the desired root. So we will do this programming in MATLAB, like implement the bisection method in MATLAB. So before that, let's see the algorithm. Is that we choose two real numbers a and b such that f of a into f of b is less than 0. Obviously you know the reason, that if it is less than 0, the root will lie between a and b. This implies that root lies between a and b. Okay, then next what will you do? You will set p is equal to a plus b divided by 2, as I have shown you in the figure also, that how you shorten the length to find the root. And then what you will do? You will search that whether f of a into f of p is less than 0. If it is, then obviously the root will between a and p. This implies that root is in between a and p. Okay, so then what you can do for the programming, you can set b is equal to p and then go to step 2. Okay, and if this condition is not satisfied, that if it is greater than 0, then obviously the root will lie between p and b. And in that case you will set a is equal to p and then again go to step 2. Now luckily, if you find out this p and if the midpoint is only the root, then what will happen? You will get f of p will be equal to 0. So it means that p is a root of equation, and then we can come out of the loop. The other thing which you can see is that this is a quadratic equation. So it will have two roots, but the bisection methods gives one root at the time. So we will restrict ourselves to the positive root only. So we have taken the value like from 0 to 10. If you go to the negative side, it will have a negative root also where it cut the x-axis. But since we know that the bisection method gives the root at one root at a time, so we have restricted ourselves in the positive root. We will positive root. Okay, so now this is the MATLAB code for the bisection method. So in this, if you want to create a function file, you can do that, and if you have a confusion, leave it for the initial classes. So what we will do, we have asked the user to give the value of a and b. That is, you have a function this for which you want to find out the root, and firstly you ask the user to enter the value of a and b. Now what this is doing, it is checking that if f of a into f of b is greater than 0 or not. This means that if it is greater than 0, we have chosen a wrong a and b, so it will display an error message. And if f of a into f of b is less than 0, obviously this will go to the else statement. Like if this is greater than 0, then display the wrong, that this is a wrong choice of the initial condition. Else, that means that this should be, if it is less than 0, then it will do what? It will calculate the value of p, that is equal to a plus b divided by 2, and then it will calculate e, that is the absolute value of f of p. That is, it will calculate f of p, and if it is near to root, its value will be around 0. You know that if we hit the root, it will be nearly equal to 0. So this is just that it is taking the magnitude of absolute value of f of p. So by these both, we can start the while loop. So what is it doing, that if suppose that while this is error is greater than 10 to the power minus 4, this is equivalent to this, you can write it like this also. If this is your error is greater than this, then you can do the following statement. If it is not, like if in the first step only you hit the root, it will come out of the loop and it will display p. But let's suppose that at the first step we didn't find the root, and then it will enter this loop, and then it will check that whether f of a into f of p is less than 0 or not. You can you know that, okay, if this and this multiplication is less than 0, then the root will lie between this. So we will upgrade our b with this value p. Else what we need to do, we have to upgrade a with p, and this if statement will end over here, and then what we will do, we will again calculate p is equal to a plus b divided by 2. Now you can see that this a or b will be the upgraded one, because now if this enters into if statement, then obviously either this will satisfy or this will satisfy, so our a and b will be changed. So this p will be something different from this, as we here a will be assigned or v will be assigned some different value, that is p. So it will again calculate p, that is a plus b divided by 2, and then again it will calculate the error, that is the absolute value of f of p, and then it will again go to this statement while and check that whether again the error is greater than this or not, and it will continue to do until the error becomes less than 10 to the power minus 4. As soon as this will be less, then it will come out of the loop. This is the end of the while loop. When it is not satisfied, then it will automatically come out of the loop and display the value of p, which is our desired output. So I have run this program in MATLAB, and then I have got the output as this. So graphically also you can see that you are getting the root somewhere near this 4.44. You can easily see that this value is near about 4.44. So we can find this by bisection method also. I have pasted this in my MATLAB, pasted the code in the MATLAB, and then I run this. So it is asking enter the value of A. So I have put 0. Then it is asking enter the value of B. So I'll put 6. Then you can see that it is giving the desired result. Bisection method is clear. Thank you.